Welcome to episode 2 of the Welding Codex. This is a podcast for those who want to learn more about the technical side of welding. We are going to talk philosophy of welding, welding codes, welding defects, and topics such as that. My name is Garry Pace. I'm a welding engineer, and the other two hosts of the program are Peter Kinney and Joel Christie. Both are Ohio State welding engineers. In this episode, Peter Kinney and I start our deep dive into AWS D1.1 structural welding code. Our plan at this point is to have a yet as undetermined number of podcasts to cover this welding code. It is going to be a slow grind through the structural welding code covering the following clauses in the code. General requirements, number 1. These are the 2020 version. Normative references, clause 2. Clause 3, terms and definition. Clause 4, design of welded connection. Note, we're going to be bouncing back and forth between the 2015 and 2020 versions of the code and outlining a few of the changes in content and format. So that's where we're headed for this episode. If you have ever wished for a podcast where a couple of welding engineers slowly dissect AWS D1.1, then this podcast is for you. Or if you have a 5-year-old that you need help getting to sleep, this podcast might also be of use. Anyhow, thanks for joining us. Pete, you want to tell us a little bit about yourself?
So I'm a degreed welding engineer from Ohio State. I have a PE in multiple states with centered on welding. I have a CWI. I'm a level 3 in VT. I'm chairman of the inspection group for AWS D1.1. I've been in various industries from heavy civil, building bridges, wind towers, buildings, to subsea pipelines, subsea equipment, various items for the Department of Defense.
All right, and you guys might have listened to me on my YouTube channel. My name's Garry Pace. I'm a degreed welding engineer. I got my bachelor's degree from Montana Tech in Butte, Montana. I'm a licensed professional engineer in a number of states, and I took it in civil, but there is no welding PE, but I practice generally in welding engineering. All that being said, Pete and I worked together previously 5-6 years ago. That's how our paths crossed. So we're going to do a quick overview of AWS D1.1. AWS D1.1 is a welding code for structural steel. It's not for farm equipment. It's not for pressure vessels. It's not for hydraulic cylinders. It's for buildings.
Well, you're right. So D1.1 is kind of one of those, what the code was written for and what people apply it for, I would say, are two different things. Garry, you're right. It was mainly geared for large steel or steel structures, buildings, light poles, wind towers, a whole array of stuff. And you're right, it was not geared for pressure vessels or farm equipment, though it's been applied to things that maybe it shouldn't be applied to. Like I know a lot of vehicles, like heavy vehicles, sometimes they use D1.1, even though there's other D1 codes that may be more applicable, but a lot of people just apply it and just because they know it. They don't know of other codes that may be better suited for that application. But you're right, Garry. It becomes a dumping ground.
Well, and I throw that out there because in my first job, I worked for a company making hydraulic cylinders. We made hydraulic cylinders for John Deere, Cat, Case, just about anybody that needed a hydraulic cylinder. And I had a conversation with a design engineer, and he's like, well, just weld it to AWS D1.1. And I told him, I was like, D1.1 isn't applicable to this application. So that's why I'm throwing it out there, because a lot of people get mired down, well, I'm going to weld this aluminum, or I'm going to weld this stainless, or I've got this Lithuanian specialty metal, and we're going to make some kind of widget out of it. We're going to use D1.1. And there's a lot of codes out there that might be better suited for that application.
I agree with you wholeheartedly, Garry.
Okay, so I'm going to just read down. There's 9. Pete always calls them sections, but in the code they're called clauses.
Yeah, they call them clauses now.
So those are basically the 9 chapters. D1.1 is broken up into these 9 clauses or chapters, and then it's got a whole slew of annexes. The annexes are there to kind of steer you through things. Annexes are extra stuff that goes with the code. So
actually, there's now 11, Garry. In the 2020, they have 11 now.
Oh, All right. So I'm going to read through the 9 that I know of. You've got the general requirements, which is 1. Design of welded connections, which is 2. Pre-qualification is 3. Qualification is 4. And qualification is for general requirements, WPSs, and performance. Performance is qualifying people. 5 is fabrication. 6 is inspection. 7 stud welding. 8 is strengthening and repair of existing structures. And 9 is tubular structures.
All
what
right,
are
so
10 and 11?
So that's the 2015 layout. The 2020 has had a huge rewrite, and now since they're now 5-year cycles, you're going to see big changes between a fifth. Before it used to be on a 2-year, now it's on a 5-year. So what AWS's new goal is to make all the codes somewhat the same. Where if you look at the same section in D1.1 versus, let's say, D1.2 aluminum, if you go to section 5.5, it's talking about the same stuff. Now, 5.5 may not be applicable in aluminum as it is in stainless, or it might be in structural steel, but it would still be there, and it would just say not applicable. So now it is, the first one is general requirements. Number 2 is normative references. Number 3 is terms and definitions. Number 4 is design of welded connections. 5 is pre-qualification of WPSs. 6 is qualification. 7 is fabrication. 8 is inspection. 9 is stud welding. 10 is tubular structures. And 11 is strengthening and repair. And then, as you said, there's a lot of annexes. A through T are all annexes in there, and then followed up by the commentary, which is I think unique to the AWS codes, and I wish other codes did a commentary as well.
This one we're going to dive into general requirements, and I don't know how much did they reword the general requirements.
The general requirements, they were generally left alone, where it basically just deals out, hey, you have the scope of what this document covers, and then it just goes through with a quick introductory of every single clause. But it's basically between 2020 and 2015, there's almost no changes. It's just numbers may have changed.
The first part, before you dive into the code, you need to look at the scope. The scope is going to tell you what does this code cover. Almost all codes have a scope. So you dive into that, and it's going to tell you, all right, this is what it covers. Do this, don't do this. So 1.1 is the scope. Go ahead, Pete.
So this one is basically, it's the scope required that contains the requirements for fabricating and erecting steel structures. When this code is stipulated in contract documents, conformance with all provisions of the code shall be required, except for the provisions that the engineer or contract documents specifically modifies or exempts.
Okay, so that's a key word there, the engineer. I've dealt with inspectors that are like, well, this is against the code. Well, if that engineer comes out and says, hey, we're going to do it this way, I want it sprinkled with fairy dust, magic powder, and eagle feathers, by God, you are going to do it that way. It's on the engineer of record. If he's got some situation in that configuration that he wants done, you as a inspector or somebody building it can raise a question and say, hey, engineer guy, I don't think this is exactly right. But if they say yes, but we've taken it into consideration, we've done the calculations, this is why we're doing it this way, you're out of it. The engineer has a lot of power in this code, in all codes. Go ahead.
Correct.
Pete.
No, I agree. And D1.1 was written with the idea of like buildings, and D1.1 originally back in the day also covered bridges, heavy civil stuff where you have an engineer of record. That is the person who designed it. So on a lot of jobs, I'm an engineer, but I'm not the engineer of record, which is what this code is really talking about. So if you were building some widget for an airplane, and as Garry said, they called out, hey, do it to D1.1, and it's like, hey, this is funny, you put in an RFI or something, or another kind of however the question method works, to ask, why are we doing it to this code? The engineer may have a very good reason why, and they can explain it, and hopefully it makes sense. If it doesn't, well, you could just put forth your disagreement and do it the way that they have told you how to do it.
The way the engineering world works is there's an engineer of record. Pete and I have a stamp for every state that we're licensed in. We have a stamp. So if I put together a failure analysis document for some company here in Houston, I will sign that, stamp it, sign my name. It's got my professional engineering number, all that stuff on it, all that pertinent information. So I would be the engineer of record. If Pete's looking through my calculations or whatever and says, hey, something's up, he's supposed to come to me and talk to me and say, hey, dude, I think you messed something here. So that's kind of how it works in the engineer of record zone. So I'm going to read under limitations. If you read through the limitations, this code was specifically developed to welded steel structures that utilize carbon and low alloy steels that are an eighth of an inch or thicker with a minimum specified yield strength of 100 KSI or less. This code may be suitable to govern structural fabrications outside the scope of intended purpose. However, the engineer should evaluate such suitability and based on such evaluations incorporate into the contract documents. And then it goes on and on and on. And then it tells you that there's other codes that are more applicable. D1.2 is for aluminum, 1.3 is for sheet steel, 1.6 is for stainless steel, 1.7 is strengthening of existing structures. So there's other codes, and then they, like Pete said, some point in the past they decided this is pretty similar to structural, but we need our own little game here. Our rules of monopoly are significantly different enough that we don't need to do it the same way that the building people are. So they split it out there.
Correct. You're right. Yeah, that's a good analogy. The monopoly game rules are different. There is a lot of cross-pollination between them, even between like how aluminum, stainless, bridge. There's a lot of things that are the same, but they're different enough that the board may be the same, but the rules are different, so they get their own code.
Right. And if you look at it from that aspect, there's more specialization because it's all welding, but there's enough subtleties there that they need their own code. So that's why there's limitations, and they tell you, hey, even though I don't know what the percentage is, but a large degree of the materials that are used in construction of structural steel and bridges, there's enough, most of those materials are going to be pretty similar. Carbon steels, and you're going to weld them with low carbon steels, filler materials. And there might be some, but you'd have applications in the bridge welding code where there's probably more dynamic loading and cyclical loading and situations that you might not see necessarily in an AWS D1.1 application.
Correct. I'd agree with that.
That's on limitations. So then we're going to go to definitions. I'm going to read a couple of these definitions.
In the new one, Gary, they throw that into a whole, that was one of the new ones. They have a whole thing of definitions.
All right, then we'll cover that in a different one. But I'm just going to throw out real quick, because this is 2015 version, but you've got the engineer and the contractor. The engineer is the duly designated individual who acts for and on the behalf of the owner on all matters within the scope of the code. That is the engineer. They're the end of the line because they're the ones that are signing it. If that bridge collapses and he's the engineer of record, that's the guy that's going to jail or getting yarded in front of Congress. That's the person that's going to be answering questions.
Yep.
The contractor shall be defined as any company or individual representing a company responsible for the fabrication, erection, manufacturing, or welding in conformance with the provisions in this code. Contractor is the guy making it. And then I'm going to cover shall, should, and may. Or you run with those, Pete.
So those three words, until you become code savvy, could really take your bacon. Shall is exactly what it is. You shall do it. You shall stand on your head and drink a Diet Coke. You don't have the option. You have to do it. Should is you should do it, but you don't have to do it. It's a recommended practice.
You should do it, but we're not going to line you up against the wall, give you a cigarette and a blindfold if you don't do it. But it'd be a really, really good idea to do this.
Correct. And a lot of this is based on lessons learned, where you have to do something Otherwise, bad things happen. Should is, well, it helps set you up for success. May is you could do it, you don't have to do it.
It's not a super bad idea to do it, but if not, we're good with it either way. Your choice.
Exactly.
Dealer's choice. Run with it either way. The reason I'm throwing this out there, and Pete's been through a few of these battles, and I have too, where a lot of decisions that are made and arguments and just fecal matter throwing contests involved in code-related welding work comes down to those three words. And you'll be in a meeting, and I've had people, and it's like, I don't have to do that. You would like to see us do that, but I am not contractually obligated to do that. We're not doing that. Or should. Yeah, we should. You want us to write up a change order, we're going to charge you for it, and we'll do it how you want it. But we didn't plan on doing that. And then you get the shall. You need to stand up your head and drink a Diet Coke. You shall do this.
Exactly.
Is that still in there, 1.4 responsibilities?
It's now 1.7, but yes, still in there. It's just renumbered.
Okay, so responsibilities. The engineer's responsibilities. The engineer shall be responsible for the development of the contract documents that govern products or structural assemblies produced under this code. The engineer may add to, delete from, or otherwise modify the requirements of this code to meet the particular requirements of a specific structure. All requirements that modify this code shall be incorporated into contract documents. The engineer shall determine the suitability of all joint details to be used in the welded assembly. He's got the call. Having been on the engineering side, years ago, quick story, years ago we had these structures and they were holding up rebar. This was at the Hanford nuclear site. And the electrical gal, I don't know, she was on the safety committee. She wanted to know, are these things strong enough? And this was 5 years after we'd been using these. They were made out of like 4x4 angle and welded, and they were holding up just tons of rebar. Well, she wants to know if there's a calc run on them. Well, we dig up the calc, and they were reviewed. It was done by a civil structural engineer. He signed off. It was checked by another civil structural engineer, and then it was checked by the boss of the engineering department. So anyways, so I dig up these old calcs and then I work through them. Yep, they're way over designed. And then this old crazy guy that I worked with, he goes through them. He's a civil PE. So we got 5 PEs that are looking at this and have said, yep, there is nothing wrong. These things are way over designed. I've gone through the calc. And this gal is still going on about, well, do we really know? It's like, I'm telling you, there's 5 of us looked at it, and 3 of them are 3 of the most anal freaking people that I know of. These numbers are right. There's nothing wrong with it. So at that point, she should have just realized the engineers said it, backed off. And somebody, I think, took her aside and said, just drop it. You're not unraveling the sweater by pulling on this thread here. It's not happening.
Yeah.
So as an inspector or a CWI or somebody, if you're not the engineer, you need to realize that the engineer has a great deal of latitude in this code to make decisions that maybe you haven't been exposed to, but in their mind and their experience and their technical expertise, they're making a good decision. You just don't have the background to understand why or haven't crossed that path yet. So
correct. No, I agree. When it comes to all of the design stuff, when they've made their decision, now, I'm not going to say people don't make mistakes, because that has been done, but unless there's something like that you see that is really like, hey, they're saying do this, let's take your example, but this rust here has ate away like 2/3 of it. Did they know about that? That's a little different, but that would be a spin on the story that the engineer doesn't know about.
Okay, so we've described who the engineer is. Now we've got the contractor. The contractor's responsibility.
Well, do you want to go through the engineer's responsibilities real quick? There's 9 of them, and I think we could go through them real quick because there's a couple have to get highlighted.
Go ahead, run through them.
All right. The first one is just, Gary, what you spoke about. Code requirements that are applicable when specified by the engineer. That we've already dealt with that one. All additional NDT. Okay, D1.1, the only NDT that's required in there is visual.
Unless the engineer calls it out.
That's right. It's specified by the engineer. extent of verification inspection. This is a new one. When required, verification inspection is done by like a third party. Weld acceptance criteria other than what's in the code. Basically, if all you have is the code and you inspect by it, it's great. If all of a sudden they come back and they say, hey, we have to have, there could be nothing, or the welds have to be a mirror finish. Well, that has to be specified in the contract because the code says nothing about that. CVN toughness of weld metal, base material, that has to be specified.
CVN toughness is impact toughness because steels, if I weld a steel down here in Houston, it doesn't go through a ductile to brittle transition. So down here in Houston or in a warmer climate, you impact toughness. Impact is like you hit something with a hammer and is it going to break? Same steel, if we ship it up to Fairbanks, Alaska in the middle of November or December and we hit it with the same hammer, steel will break because it goes through something called a ductile to brittle transition phase. Steel will shatter. So there's special steels where they throw alloying elements, nickel, manganese, blah, 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 into the steel to give it impact toughness so that it can take a beating in a colder temperature. But it's about freezing where your garden variety coat hanger carbon steel will start to exhibit this brittleness that it doesn't at a warmer temperature. Anyways, go ahead, Pete. CVN
for non-tubular applications, whether or not the structure is statically or dynamically loaded, because that changes some of your groove designs that are used, which welds are loaded in tension versus compression, and additional requirements that aren't specifically addressed in the code, which could be all shoulds become shalls. That's a tricky one that I've seen done in contracts. Have you ran across that, Gary?
No, I haven't run across that, but I can understand how that would.
Yeah, that could be a pickle. What it really affects is when after product's already made or maybe even shipped off to the job site, it's all of a sudden someone's digging around through the contract and it says, wow, all of these shoulds become shalls. Well, we did some of them. What about the ones that we didn't do? All of a sudden that or people's memories are like, did we do this or not? That one has been a very dicey one to deal with. And this one is not as common is for OEM applications, the responsibilities of the parties. OEMs are a little different. That's basically where the engineer and let's say the prime contractor are the same. Mainly more applied to items that you would do it for like bridges or buildings or other large steel structures, but it could be definitely done for a lot of more equipment related is where they're the engineer and the fabricator all in one or contract.
So it would be like a skid, maybe an oil field skid or something like that.
That would be a very good example. That where they are both, or maybe some wind tower companies, both the tower manufacturer and the designer of the whole thing. There's some more there's different responsibilities of how they have to define what they are or are not responsible for.
So then you've got the contractor's responsibilities. The contractor, this is the person building it, shall be responsible for WPS's qualification of welding personnel, the contractor's inspection and performing work in conformance with the requirements of this code and contract documents. So the contractor's job is to come up with WPSs, whether they're pre-qualified or qualified, and then also qualification of the welding personnel. If you're going to build it to this document, all your welders need to be qualified to this document. The contractor's inspection, that might not be third party, but that's just taking care of the contractor section of inspection and making sure that everything's built to the code and that you got the contract documents, the paperwork put together correctly.
I got a question for you, Gary. But what if I'm the fabricator? Am I the contractor? The contractor is the guy, the dirt work guy, doing all the prep of the building site. But I'm the fabricator. Do I have to? Who's the contractor on that?
The contractor shall be defined as the company or that individual representing a company responsible for fabrication, erection, and manufacturing of welding in conformance with the. So to me, you could have the contractor, he is responsible, and the fabricator is the person welding it, but the contractor is responsible for making sure all that's done. What do you think?
So I'm thinking, yeah, basically it rolls down to whoever's doing the work, where they're like on a classical, let's say, building, you have the engineering firm, you have the owner, you have the contractor or the prime or the general, and then they're delegating it to all their subs. Their subs, whether the fabricator for the red iron, they would, by them receiving all the plans and whatnot, they are now being informed that they have to follow D1.1. So even though they may call themselves, well, I'm the fabricator, well, you're the same as the contractor in that sense.
Yeah, you're the contractor's representative. You've just been delegated to build the stuff. The contractor, the overall contractor is responsible, but that doesn't relieve you of any obligations under this code. You're
Correct.
still required
Exactly.
to follow the code.
I agree with that.
So then you've got, oh,
Welding
well,
symbols are simple. Yeah, I mean, basically, we just go to AWS A 2.4 standard symbols for that, and that'll basically wrap up clause one.
a lot of times when I'm talking to people about the code or you'll see questions, Pete and I every now and then will answer questions on, there's an AWS forum, but it's like, did you go to clause 1 of D1.1? Read that chapter. Before you even start asking if you can weld stainless with this, or why isn't a certain titanium alloy covered as a pre-qualified material, go read this. It tells you what this code is for. Before you do any kind of code work, dig through clause 1 of the code you're working with and read the scope, read what it's about, because if something goes sideways or you come into a meeting, somebody like me is going to start poking holes and be like, dude, you're using the wrong code. So you better dig through it and know which code you are and whether you're bringing the right equipment to the baseball game or whatever. I don't know if that's a good analogy. Thoughts?
No, I completely agree. I think a lot of people don't understand why they throw out D1.1's very probably one of the most common codes, welding wise. So people throw it out there all the time, and either they're not questioned or they understand like, hey, why am I doing this to this code? It doesn't seem very applicable, and they don't find out why. And you're right, they ask questions that probably they should have done a little bit of research before asking the question. The next one is normative references. And basically, this is a ginormous list of documents that are referenced within D1.1, and there are pages of it. So it's not something that we're going to read through. It's just, if you really need some bedtime reading, go get your hands on all those documents and read through them. They range from all the other D1 documents to your filler metal A5 specs to ANSI stuff, API. They call it a couple of those in there. There's some ASME documents that they reference in here, ASTM documents, Canadian Welding Bureau. It's a big laundry list. And if you just want to educate yourself, go get those, read through them, have fun.
Okay, so normative references is 2. What's number 3?
Number 3, one thing to say about normative references. Normative references are mandatory to the extent specified within. If D1.1 was to reference, let's say, ASTM E140, which is a hardness conversion for metals, it's now invoking what that requires. That's in a normative reference. That's probably the most important thing to know about that. Number 3 is terms and definitions. In the 2015, it was in the back of the book. They basically brought it to the front of the book. And these terms, okay, so you have AWS A 3.0, which is standard welding terms and definitions. Well, in the AWS documents, either they use exactly how A3 says it, or they have to define it within that AWS document. So if D1.1, which has been around for a long time, it was one of the original codes written by AWS, if not, it was the first one by AWS. They're a little different than what sometimes A 3.0 does, and it makes for some lively committee meetings when people want to argue about the definition of a word. But if D1.1 wants to use a word a little different than A 3.0, they have to define it. That's basically the long and short of that one.
This terms and definitions used to be in Annex J, so now they just bumped it up and moved it into 3.
You're right. They just brought it to the front of the bus.
Okay, so now, and it's basically like in the back of your textbook when you're in junior high and there's a bunch of vocabulary words in there. That's what it is. It's just like a little mini dictionary, and it explains, CVN or complete joint penetration or fatigue or whatever. I mean, there's a zillion different words in there, and it just dials everything in. So if you get into a conflict with somebody in regards to it, all right, here's the definition. This is what we're doing. Blah,
exactly.
Blah, blah.
Exactly. With the one modification of it's the welding terms or the jargon that is different than what is at A3.0. So if A3.0 says alloy flux is defined by there's alloying elements in the flux, while D1.1 calls it something a little different, D1.1 has to define it. But if it's not different than A3.0, you won't find it in this. You have to go back to A3.0. That's the only little switch up that, as compared to, as in your analogy, as this is what's in the back of your science book in 6th grade.
So then we go to 4, which is design of welded connections.
That's exactly what it is.
For 90% of humanity in the welding industry, I very rarely have ever delved into this. It tells you the scope. This is structural engineer material. This is the guy crunching numbers. The structural engineer might not do a hell of a lot with, they might not delve into too much else in the code, pre-qualification and that's not their game. But the design of welded connections is their bailiwick. You have, like any other code area clause, you've got the scope. This clause covers requirements for design of welded connection and is divided into 3 parts as follows: common requirements, specific requirements, and specified requirements for non-tubular and non-tubular. One of the changes they made in D1.1, and this is my version of the universe, is that tubular structures, if you look at the old codes from like 2000 to 1996, whatever, everything was together. Tubular structures didn't have their own, its own rule book. So basically, D1.1 took tubular structures because it was just confusing as hell. Is this a tubular structure, non-tubular? Well, it said we had to do this, but no, that's only for tubular. So the code committees just said, we're taking tubular structures, we're going to make its own mini code in the back of the book, and everything to do with tubular structures, including design and whatever, is going into this chapter clause section of the code. Is that correct, Pete?
Yeah, that is. So Garry and I both started out with it combined, and that's what I was used to for many years. They split it out. I was on fabrication and inspection at the time, and it was a big thing for a lot of work for them to split them out. But what's funny is another gentleman that had been around a lot longer than I have, he said back, I want to say it was the 70s, they were split at that point, 70s and 80s, and then they got brought together, and then now they're back to the way it was. So I guess there's some humor in that. You're right. They basically split to 2. The only time that I find it where it makes things a little more difficult is in qualification, because now you kind of have to look at 2 different areas for qualification, because tubulars are now dealt with in their own little world.
That's been split out. So the design of welded connections, and I'm not going to dig too. I think, what do I got highlighted in here that needs to be? If you look at the scope, it's going to tell you what's going on. 2.3 I got here, contract plans and specifications. So that just tells you, plan and drawing information, complete information regarding base metal specification, location, type, size, extent of all welds shall be clearly shown on the contract plans and specifications. So it's basically telling the engineer, you got to be a grown-up. You've got to tell the people making this thing exactly what you want. It tells if the engineer requires specific welds to be formed in the field, if you want field welds, they got to tell you. They need to put together fabrication and erection drawings. It basically just tells the engineer, hey, you got to be a grown-up here.
Yep,
and
I
put
agree with that.
together documents that the guys in the shop can deal with. 2.33 is shop drawing requirements. Shop drawings shall clearly indicate by welding symbols or sketches the details of groove welded joints and the preparation of base metal required to make them. Both width and thickness of steel backing shall be detailed. It gives you some guidance. It gives the engineer guidance on what they need to do. Part B is
Is
specific
for
requirements for go ahead.
is for non-tubular connections statically or dynamically or cyclically loaded.
Right, and that's statically or cyclically loaded. And then you've got part C is requirements of design of non-tubular connections, cyclically loaded. And then the other one I'm going to skip ahead here, Pete, to 218, prohibited joints and welds.
Yes, that's. I was going to say we need to hit on that one so people understand why the code is kind of written the way for the joint details anyway.
I'm going to let you run with this one. Go.
All right. So for prohibited joints, one-sided welds without backing or other backing made without steel that's not qualified. We're talking about pre-qualified joints here. So when we get to the pre-qualified portion, you'll see everything is either has backing or is back gouged. There is no, for like our piping guys, there's no open roots where you just weld it from one side. There's no, hey, can I use a ceramic backer? Can I use a ceramic backer with some flux? Can I put a fire hose down, put flux on it, put a little bit of air in it and weld over it? No, we can't. It either has to be back gouged or made with backing. So that's the one unique thing that's pre-qualified. Now you can qualify, if you qualify it, that second part of that sentence, other than steel that has not been qualified. So if you qualify it, you can do a lot more stuff.
And we're kind of getting ahead of ourselves, but in AWS, you've got pre-qualified, I'm going to throw out some terms here. You've got pre-qualified weld joints and qualified. So if you're pre-qualifying something, that's like your garden variety carbon steels. The code recognizes that for the last 100 years, they've been welding steel A to steel B with 7018, and it works. You can do this. You don't have to qualify it. We're just going to take it at face value. If you act like a grown-up, you wipe off the water, you're dry, you do a little preheat, you follow the rules, the weld's going to come out good. We don't need to qualify 7018 every time we're going to do it if you're going to do this joint configuration and this metal to this metal. And then you have, like Pete was saying, you have qualified weld procedures where maybe you're using a metal in a different type of metal or a steel that doesn't fall into one of the pre-qualified steels. It's a little different, and you're going to use that in a situation, and maybe you want to use a filler metal that doesn't fall in there. You can qualify it. So you just do some bends, some tensile tests, and whatever testing that the code requires, and then you've got a qualified procedure. So we're kind of getting ahead of ourselves, but those words came up, so I just wanted to get everybody. There's a lot of angst and confusion when it's a pre-qualified. No, you're using something that's not on the list. You got to go qualify it. Or why are you qualifying this? You could have used a pre-qualified. So anything else we need in the prohibited joints there, Pete?
I don't think so. I mean, I think that's the main one. I mean, everything else dives a little deeper into unique situations, but I think that's the biggest one. And folks got to remember, this is for cyclically loaded details, which some buildings, even though we think they are static, but when you get into like real big high rises, some parts actually are now considered cyclically loaded. So they actually dance a little bit. The other thing I wanted to point out is table 4.2. This will only ever really be used if you have TKY kind of joints. But this is where that table is found, your Z-loss dimension. It's not very common. If you're in the structural piping side where you're building structures out of pipe, you will learn about this table.
Yeah, I haven't dealt too much with that. I haven't dove into that too much. But for 90% of the population that deals with welding, odds are you're not going to go into clause 2 here. The number of times I've gone in there has been very, very limited. It doesn't happen very often. Most of the meat, you're in either the general requirements, or you're in pre-qualified, or you're in qualification or fabrication or inspection. You're usually swimming in another part of the pool. As an inspection guy, you're generally not in design of welded connections.
Correct. There are some other figures just that would be educational, which is like your maximum fillet weld size along edges and lap joints. There's a good picture there. And it's good to know these pictures. To one thing is to show welders a lot of times in the field, hey, look at this. This is what's wrong. This is why we're doing it's wrong. Or like transition joints from like something that is 2 inches thick down to 1 inch thick. Or where do you do holdbacks on edges of members for fillet welds, or fillet welds on opposite sides of a common plane? That's a lot of them. Do you wrap the corner or not? There is some guidance in here on when that is and isn't done.
Yeah, and there's, like you say, there's in those tables towards the end of clause 2, there's a lot of diagrams that can be very educational in regards to showing people what they need to know, or, okay, maybe this is a little better picture of how we need to do this or why we're doing it this way, and design of welded connections. All right, that wraps up our first 4 clauses in AWS D1.1 2020 Structural Steel Welding Code. Sorry for bouncing back and forth. We were working out of 2 codes. But anyways, today we covered general requirements, which is clause 1, normative references, which is clause 2, clause 3 was terms and definitions, and clause 4 was design a welded connection. As Pete said, a lot of the changes in the 2020 version of the code were just involved in moving things around and formatting. And this was done because the AWS committees are trying to make the codes more consistent in their format and layout. The next couple of episodes, we're going to be grinding our way through clause 5, which is pre-qualification of WPSs, which will then dovetail into clause 5 qualification. Thanks for listening. Hope this podcast was worth listening to. We're going to have more content coming out. Also, if you want to shoot me an email, gpacex@gmail.com. Give me some ideas, or maybe there's some questions that you'd like me and Pete or me and Joel to answer in regards to welding codes, filler material, or any other material joining question that you might think we have a shot in hell of answering. Anyways, thanks for listening. Take care. Peace out. If you like these podcasts, stop by my website, texasweldingengineering.com, and go to the donation page. Use PayPal, throw me $1 or $2 so that the next time we hit the local Dairy Queen, we can get a large chocolate chip cookie dough blizzard. Also, if you're looking for CWI training at a reasonable price, check out train-eng.com. Also, if you're not familiar with my YouTube channel, there's a bunch of YouTube videos on there. If you just do a Google search under Garry, Pace, Welding, ASME, or AWS D1.1, there's a bunch of videos on there. Check those out too if you're interested.